Hey, this is Steven from the Green Engineers, and welcome to part 2 of my update. This is the same day. This is a few minutes later. I decided I didn't get into as much as I would like to in my last update into getting you guys all up to speed. So I'm going to do another 11¼ minute video, and I'm going to finish up with talking about the shredder and then go into filafactory and other things that are happening. So yeah, basically I'm going to enlist the help of somebody to clean up all these. There's about 300 parts, so to clean up all these, and then if I get a chance to do a basically just a piece that goes onto the arbor press with some set screws and holds this guy over the over this punch, I will have them punch it as well. But the idea, because I'm pretty short on time as far as school and work is concerned, so have somebody do that as well as clean this up. Or what I might have them do in the meantime is clean up these parts, do all the kind of manual labor of knocking the dross off all these parts, and then 3D print some guides where basically it's the size of the shredder with each of the rotation here, or circle in the center. What we'll probably do is basically a copy of the shredder with the circle in the center, and then if this square is outside the circle, it's out of tolerance, and we're just gonna throw it away. So what he'll do, again, knock the dross off and then clean up the face of it. If it's in tolerance, so what he'll do, put it on top. If it's within tolerance, he'll start to clean it up, knock the dross off, sand it all nice, get it nice and cleaned up, getting it ready to be broached. Because again, this has to be flat because it's going to sit on this guy. So there can't be any dross around this edge like this. Can't be a dross around this outer edge. The outer edge is okay because you see it just needs to fit. It just needs to sit flat. This one I did already? No. Yeah, you can see just how little it takes off. It just takes off a little bit because there's just a little bit of taper there. So at that point, we'll have I'm going to prioritize the 1055 steel over the A36, and also grind all this aberration stuff off. Grind the taper flat, and then sharpen the blade. So that is basically what's going to happen here. Sharpen that blade there, open this up, nice and flat on the grinder. So I'm going to find somebody at the shop that could possibly do that, hopefully to get us all set up for finishing it in as little time as possible. And then I need to get another one of these shafts. And then this was actually really expensive. This was a piece of tool steel for a broach to push these guys, but I see that that this guy worked pretty well, and this guy was, I think, slightly over. It was quite a bit over. This is 830. So probably not going to end up using this guy as a push broach, but we might need to if this doesn't work out and I want to finish it before San Francisco comes back up in about a month from now. So that is the situation on the shredder. So it's looking really good. This push broach worked way better than I expected. I expected it not to work that well, but it cleaned up and chased these holes brilliantly. So now the question is, for the people that have pre-ordered, do I have enough parts, and could I get this to be good enough quality to release? Which I think with quite a bit of cleanup, maybe 5 minutes apart or something like that, I think we could. So yeah, that is these parts. Again, I don't think I'm gonna be using this piece of I think it was A2 tool steel. So that is the status on the shredder. Shredder is looking pretty good. Obviously, once I make all of these, then the next step is to go into a faster mode of production, which is to build my water jet. So that is what's after building these. I think I have 8 shredders worth in that bucket. So once I sell those out, I will begin production on the water jet. So while those are selling, after I graduate in a month and a half in the end of May, I'll be working on the water jet while these shredders are selling. And hopefully once the shredders are sold, I'll have my water jet. I'll have some 2x2 sheets of 1055 steel, again from the same place that these are from, and then start producing. Okay, so here's some stuff from to kind of show you guys of the status on the on the filafactory. So here are some parts that I've machined. So this guy, I just machined this last weekend, and again, this is kind of one of my priority projects because for some reason I picked this guy as my senior project. I probably should have picked some of these other ongoing projects, but obviously filafactory is my version 2 of my filament maker, the multi-shooter, and they're going to use the same exact firmware. So I'm working on the firmware as well for the multi-shooter and the filafactory as we speak. So this is the barrel. So this is a 6061 aluminum, and it's turned down on a manual lathe to 1.79 inches OD, and it has a drill that's been passed through it. That's a 0.98 drill for fine taper screw for fine thread screws, FNPT threads, in order for the nozzle to seal completely without using Teflon tape. So as you see there, that's what's going on. So what needs to be, I just finalized the OD of this guy last weekend, which was 2 days ago. And this guy will go in here. So these are regular 3D printer 40-watt heaters, and then there will be a hole drilled, and then these guys will go right into the hole as you see here. So I'm going to 3D print a piece that goes around probably the ID. The OD might work, but probably goes inside the ID, and it has some holes here that will allow us to manually drill this so it's perfectly straight here and also in the perfect location here. Reason why that needs to be perfect is that here is the nozzle. Obviously threads have not been cut yet, but you see here, and then here I was turning down the OD a little bit, and I got a little too tight on the vise, on the 3-jaw, so I kind of turned the edge, but it's fine. So this has got a 4mm? I think it's a 4mm hole. I'll have to double check, but I believe it's a 4mm hole, and it's got a 45-degree taper into the hole, so the plastic's going to help it flow more into that hole. And then this flat spot in here is big enough to kind of help start cooling it down and forming it. This is again 6061 aluminum, and this will be there will be most likely. So I'm still deciding between fine NPT and straight thread. So I'm still trying to decide on that for the outside of this guy. So again, this guy, once it's threaded, will spin into this guy, and because it has a hex, it's actually set up to be removed. So there is a socket that I'm looking at that needs to have the clearance for these wires, as these wires are sitting in here. So basically what I did is I modeled these in Fusion, and this was already modeled in Fusion. I stuck it in there, and then I had my nozzle on there. I basically had a socket. I basically looked around the shop, found a socket, and then had it set up for the clearance for the socket. Because again, this guy being as thin as possible is the optimal situation, as we have more conduction throughout the barrel from these two 40-watt heaters and the insulation around the outside. So we want as much of that heat to go down as possible. So we want this guy to be as minimal thickness as possible. Probably in the future and in production, we'll have our own socket that's turned down to its bare minimum, or maybe even a 3D printed socket that will be used to take this guy off, so we could get this this OD down even smaller. Now here's what I call the torque plate. This started its life as a piece of diamond plates, and you can see here some corrosion on the backside. I didn't even notice that when I bought the piece. But it started its life as a piece of slightly oversized diamond plate, and was cut on the Tormach 440 at the shop. And so basically this guy, the reason why it's called a torque plate is it has two holes here. And the two holes go on the back side of the extrusion barrel, like so. And the motor, the NEMA 23, I think it's either 23 or 24, I'll have to look at it again. It goes onto this side, and this is clearance for that NEMA 24. And here are the mounting holes for it. So this guy holds on our motor. So basically this inside of the machine is one of the only high stress parts. So that goes here, and so keeps the motor attached rigidly to the barrel. So other things, we have a quarter of a second, quarter of a minute. So other things are software and printing out the housing and finalizing all the fixtures by a month and a half. So spring break's coming up, a lot to happen then. This has been Steven from the Green Engineers. I'd like to thank you guys for watching. Stay tuned for my next update. I'll see you guys in the next video. Thanks for watching. Take it easy. Peace.